Hello, we're back for part 3 for inflation, part 3 lecture, and we're going to start out with what is known as the real value equation. This actually is not in the textbook, which I find, I like the textbook, but there are a few things I don't like, and one of them is that it leaves out a very useful equation, the real value equation. Of all the equations that I've used in my own personal life that are in macroeconomics, this might be the one I've used the most. Very useful tool. By using this equation, I can turn any nominal values into real values. And so here you take the nominal value for any year, year Z, divided by the CPI for that same year. And so we need the CPI numbers. And you can find CPI numbers going back, 1920s, maybe even earlier, at the Bureau of Labor Statistics. You have to do a little searching there. And then you times by what is known as the CPI for the comparison year. Now, what is a comparison year? Well, whoever creates the data, whoever does the calculations, can pick any year as a comparison year. So this equation, I could convert any nominal values into constant values based on the prices that existed in any given year. So I could pick 2000 is the comparison year, 2001, 2002, the base year, doesn't matter. Many times the base year is what's chosen as the comparison year, but I prefer to maybe pick a current year as a comparison year because it brings dollar values closer to people looking right now. If I use the base year, then that will convert all of the nominal values into real values in prices that existed during 1982, 83, 84, but people living today don't know what a dollar could buy back then. You do know what a dollar can buy today. And so what I'm going to do here is I'm going to pick 2019 in this example for the comparison year. And so what I have over here is I have 4 years, and these are the actual CPI numbers for each of those 4 years. I've actually rounded them to the first decimal point just to make it a little bit easier for the calculations. And here I made up some 4 numbers for someone's nominal income. So if someone earned say $70,000 in 2016, received a $1,000 pay increase for 17, another $1,000 pay increase for 2018, and then another $1,000 for 2019. Now we can't really compare these. Well, we can't compare these numbers because they're based on different prices for what these dollars could buy. So these dollars back here can buy things at lower prices than the dollars up here because CPI is higher here than there. So I cannot compare these numbers here. I don't know if you're being paid more. You can actually be being paid less. I don't know. So you have to convert them into real numbers. And so what we do is simply use the equation right here. We take the nominal number, which is 70,000. Here the dollars will stay. Divide by the CPI for that year, which is 240.0. And then you times that by the comparison year, which is 2019 prices. You use 255.7. This would be times 255.7. And because I'm timesing by a higher number than I'm dividing by, it's going to increase that. And so I take 70,000, divide that by 240, times that by 255.7, and I got $74,579. Now, what does that number tell us? Well, it tells us the following. It tells us that $70,000 back in 2016 has the same purchasing power as $74,579 in 2019. So this could buy as much in 2016 as this could buy in 2019. Do the next one. You take 71,000. Keep the dollar sign there. You divide by its CPI, which is 245.1, and then I times by the same number up here. If I times by a different number, then I'm doing nothing. I got to times by the same comparison because I want to change all these nominal values into what they could buy in 2019. So you take 71,000, divide that by 245.1, times that by 255.7, and I got 74,007, and I round up to a dollar there. So $71,000 in 2017 has the same purchasing power as $74,071 in 2019. So that means this money here is actually worth more than what it can buy than this money here. This money here, $70,000 in 2016, has higher purchasing power than this money here. How much higher? Over $500 in terms of 2019 prices. To the next one, we take 72,000, divide by its CPI, which is 251.1, and again times by the same number we did in the first two calculations. And so we take 72,000 times that by, divide by that by, so 72,000. Divide that by 251.1 times that by 255.7, and that gives us $73,319. I'll round to the nearest whole dollar. So nominal value is going up, nominal pay is going up, real value is going down. So $72,000 in 2018 can buy as much as $73,319 in 2019. So you can see in real term, the person is going down. And the last takes 3,000 divided by 255.7 times by 255.7. That one's easy, right? We're basing all the prices in 2019. $73,000 in 2019 can buy as much as $73,000 in 2019. So what does this tell us about the nominal pay? It wasn't enough. The nominal pay did not keep up with inflation, and that's one of the problems with inflation, is that if your wages don't keep up with inflation, your real purchasing power of your income goes down. And that's why this is a very useful tool. This person should go to the employer and say, look, I know you've been giving me more money in terms of nominal pay, but it has not kept up with inflation. In real terms, my pay is buying, what, over $1,500 less than it did back in 2016 using 2019 prices. Do another one. We can look at the real price of a gallon of gasoline. Gasoline prices is something that most Americans, especially people in Southern California, are aware of. And so if you go back and look at videos in the past, go say 1980, and you see that the price of a gallon of gas is $1.25, you might think, well, things were pretty good back then. Well, again, that's not a fair statement because we don't know. Because again, $1.25 is lower than what we pay today. However, prices were lower back then, and so that $1.25 was worth a lot more than $1.25 today. So how much more? Let's figure it out. Let's use 2019 as a comparison year again. And so we take the $1.25, and I got these nominal prices from the Bureau of Labor Statistics. And so you take $1.25, you divide it by CPI, which going to my box is 82.4, and then we times by again 255.7. And so $1.25 divided by 82.4 times that by 255.7, and that gives us 388. So that means when people paid $1.25 for a gallon of gas back in 1980, that's equivalent to paying $3.88 today for a gallon of gas, or at least 2019. So $1.25 means a lot more than just $1.25. Do the same thing for 2090. You would take $1.16. Can't write. You would take $1.16. You would divide that by 130.7, and you times that all again by 255.7. So $1.16 divided by 130.7 times that by 255.7, $2.27. Then we take 172.2, divide that by, whoops, I should maybe just write it down, I won't make mistakes. 131 divided by 172.2, and then we times by 255.7. So $1.31 divided by 172.2 times by 255.7, gives us $1.95. So price of gasoline in real terms has been coming down from 1980 to 2000. The reason why price of gasoline was really high in 1980, we'll talk about that. We'll talk about stagflation of the 70s. I showed you the real high inflation of the 70s. Well, that was partly caused by higher oil prices, and that led to really higher prices in gasoline. And this one, again, we don't do any calculation. It's in 2019 prices, 2019. So actually, gasoline was more expensive back in 1980 in real terms than it is in, say, 2019. And I'll stop there. We've gone over 10 minutes, and we'll come back and do a couple more examples of real value.